finish up that section. So it takes 2 days to do it. Today we are rationalizing. Now we've done a little bit of rationalizing. So if I had 7 over root 5, let's just throw root 2 up there just for the heck of it. How do I rationalize that? Over root 5. Okay? Because that's a 1. That's all I'm doing. Now I have 5 root 10 all over root 25. I can do the square root of 25 and I get a 5. Does anyone need to see another that is like that? Just show me you get it. Let's try this one. Do that one on your own. Okay, Kaylee, what do we multiply by?
The square root of 7.
And what do we get at the top?
3, the square root of 14.
And at the denominator?
49.
And the square root of 49 is?
7.
7. Who got that correct? Anyone confused on that? Okay, so now we are going to get to the actual hard ones. Before we actually do a hard one, I want us to do this multiplication problem. How do I multiply that? Yes. We do the whole FOIL distribute thing, so we get 5 times 5 is? And then 5 times negative root 2.
Minus 5.
Yeah, minus 5 root 2. And then we do this. And then the last thing is minus what?
4.
Square root 4. Why could I add those? That's the, because I'm multiplying, right? No, I didn't add them, I multiplied them, so I add the exponents of what I meant. Or just 2 times 2 is root 4. Root 4 is simply 2. And then what happens to those?
Combine because it's the same.
Right. So I get a 0. So I don't need to write that. I get in the end 23. Try this one. And then after you're done, I want someone to make an observation about the 2 things that we're multiplying. But for now, just multiply it. That's a mental smile. When you played in church, I'm going to try to get you to my stuff. And make you face it down.
I'm not going with you.
When you're done, check your answer with what I have up here.
Is that there?
Who's confused on multiplying this? Okay, Sarah, what part are you not getting?
Putting it all together.
All right, so did you get this line right here?
Yeah.
Okay. What's the square root of 4 squared?
2 squared.
Okay, so do you see where I got that?
Um,
And the square root of 9 is 3. But look at this part. Those are simply like terms. I can find them. What's 24 minus 24?
0.
0. So all I did was I actually did that square root, because whenever you can do the square root, you do the square root. All right, so what's 72 minus 48?
24.
Okay, who got that correct?
I didn't try it.
Does anyone need another practice on multiplying those? Okay, I want you to take a look at this. Observe something about those two things.
Oh, it's the thingies.
They're exactly the same, except one of them has a minus and one of them has a plus. That actually gets us to how we're going to do the difficult problems. Those are called conjugates. Conjugates are binomials whose only difference is the sign in the middle. So if I wrote 5 plus 7 root 9, well, not root 9 because I could just do that, root 6, its conjugate would be what?
5 minus 7 or 6.
Those are conjugates. And if I had 6 root 3 plus 2 root 11, what's its conjugate?
6 root 3 minus 2 root 11.
And let's do one more just to make me happy.
It's going to be 5 square root 2 plus 7.
Okay, so these are all conjugates. Do you see what a conjugate is?
Yes.
Now, conjugates in the case of radicals have a very important property. So I'm just going to step back to this slide. Even though I had roots at the beginning, look at my answers. Do I have any roots? They canceled out. Okay, so that is a very important property. The roots will, in the end, go away if I multiply them. That is their property. Let's try one more, and then we are going to actually see what we'll use the conjugates for. So let's say I want to multiply 5 root 2 minus 7 times 5 root 2 plus 7. Let's actually multiply that out. We'll do it together. So I take the first thing, multiply it by both of these. So what do I get when I do that, Reagan?
25 root 4.
And then plus 35 root 2. Anyone have a question where I got that? Now I'm going to do negative 7. I'm going to take that sign with it and multiply the rest. So minus 35 root 2. My thing would cooperate.
It's the same thing as when the factor.
Minus 40. Yeah, it's the same thing as when we were just before we did factoring. The square root of 4 is 2. So I have 25 times 2. Any questions where I got that? I'm not hearing you, so I guess that means there's none. All right, so 35 minus 35 is 0. So that's 0, plus 0. And then nothing to evaluate there, minus 49. Now this is 50 minus 49, which is 1. 1. Our answer is 1. Now here's what we're going to use that for. Remember, can I have a radical in my denominator?
No.
So what if I have something like this? Now you might think, I'm about to do it wrong, so don't write this down. You might think, oh, there's a root 2 there. Multiply by root 2 over root 2 like we were doing before. But notice, if I do that, I get 6 root 2 at the top, and at the bottom, yeah, that takes care of this part. I get 5 root 4. But notice this part. Now I have minus 7 root 2, and I haven't actually taken care of it. I've just made it even worse. So this is that root 4 is 2, so I get 10 minus 7 root 2. And then you might think, oh, we'll just do it again. In which case, now the root 2 is just going to be switching between those. Do you get what I'm saying there? And then an endless cycle. So I do not want to do it that way. That is horrible. So what was the problem I had there?
6 over 5 square root 2 minus 7.
So to simplify that, to rationalize, I'm going to use the conjugate. So what's the conjugate of that? Well, 5 root 2 plus 7. So it's a little bit more complicated than before, but all you have to do is change the sign in the middle. So that gives me 30 root 2 plus 42. Any questions where I got that? See, I took this 6 and I multiplied it by both of those. And then at the bottom, I'm going to have to do this multiplication. 5 root 2 minus 7, 5 root 2 plus 7. Okay, so I multiply those, and I'll get 25 root 4 plus 35 root 2. And then when I do the negative 7, I get negative 35 root 2 minus 49. At the bottom, this is going to become a 50. Okay, and those cancel to 0. So I'm not showing all my work here. At the bottom, I get 1. Okay?
If it was a 1, would you have to put it over 1, or would you just
Nope.
leave it?
I don't need the over 1. In fact, you probably shouldn't even write it. Now, I want you practicing all these different things today, so I'm really just going to show you one more thing. And that is, well, what if I do all this and I get this answer? Let's say 15. Okay, if I leave my answer like that, it's wrong. Okay? Now I'm saying, suppose I did something and at the end, this is what I get. What I need to do is I need to look at these 3 things that I'm circling. Okay? And do you notice something I could divide all of them by?
5.
I could divide them by 5. Notice I have to divide all of them by 5, not include. I'll try again. I have to divide all of them by 5, but not including the radicals. So 15 divided 5 is 3, 20 divided 5 is 4, and 15 divided 5 is 3. Now this is the right answer. I have to reduce. And the reason that worked is I actually, if you look at the top, if I have 15 root 3 plus 20, do you see something you could factor out of 15 and 20? A 5. I could factor out a 5. And then do you see at the bottom, well now I could cancel that 5 with this 15. Oops. You get a 3. That's what I actually did, but the shortcut is to just divide them all by the same thing. Okay, that is it for notes. Now we're going to practice a billion of these.
Oh, billion.
On the whiteboard or paper? Whiteboard.
Well, what we're going to do is actually you're going to start on your homework.